So let's get started. As Kenny said, in the keynote speech earlier, we introduced sort of a high-level vision of model-based design. Some of those ideas were abstract, and in this model, or in this particular session, we're going to drill down a little bit deeper. Okay? In particular, since it's the first session of this track, I think it's appropriate that we talk about our base fundamental platform, which is MATLAB. And more specifically, I'd like to talk about some of the new capabilities that we have in the signal processing and communications area. And I'd like to talk to you about some of the new concepts, such as system object and also MATLAB Coder. Okay? So before I get started, I always like to ask a question, right? I'd like to ask you, how many people use MATLAB on a daily basis? How many people are very, very, very familiar with MATLAB? You can raise your hand. Don't be shy. Just because I'm speaking English. It's okay. So nobody uses MATLAB. I'm surprised. So how many people have never used MATLAB? Now I'm confused. So I assume that a lot of people are familiar with MATLAB, right? Hopefully I can show you, a couple of capabilities that you haven't seen before, and let's start with that. And just like what Kenny said, if you guys have questions, certainly ask me. If you're more comfortable waiting till after the session, that's fine too. I'll be here. All right? So let's get started. First of all, and I didn't get a good sense how familiar everybody is in MATLAB. So before I get into the new stuff, I thought I might just kind of open up MATLAB and take a look at the environment, see if there's anything new here that you're not familiar with, right? So we all know that this is the basic MATLAB desktop, right? Here's the command window. And what's nice about MATLAB, we all know what's nice about MATLAB, right? MATLAB allows you to very quickly generate a signal, maybe process the signal, and look at the signal. And that's why a lot of people use MATLAB, right? Because you can very quickly do some visualization of your data. What I do here. Very quickly visualize your data. We all know how to do that, right? And that's one of the attractive nature of MATLAB, being able to very quickly create data, looking at it, analyze it, interact with it, right? Another thing you can do from the command window here in the command history is, of course, right-click and create a script. So rather than using MATLAB as sort of this advanced calculator, you could get a little more sophisticated, and you could create a little script so that you can call it, right? So I'm sure many of you have done that. You can save this off. And now you can call it from the MATLAB command window. I called that file test. You could say test, and now I can run that script. Very simple, right? Things that you know. Now, did you know that you can create comments, right? We know about this. You can create comments. This is my data. This is my algorithm. This is a plot of my data. Nice. Now some of you may not know that if you put a double percent sign, you create this thing called cells, right? This is called cell mode. Again, we're kind of just reviewing a little bit before we get into some of the new stuff, right? But this is something called cell mode. And if I wanted to now, I can execute each of these segments individually, right? So if I click on this cell, the cell is highlighted, the first cell, and I can press this button, and I've executed the first segment of the cell. If I do it again, now I've executed the second segment of the cell. And now, I'm going to click it again, and I've executed the third segment of the cell. Okay, so this is something called cell mode. Something that's pretty practical if you're debugging some MATLAB code. Speaking of debugging, over here on the left-hand side, there are these dashes. This is where you can set breakpoints, just like in C, you can set breakpoints. Okay, so that's the MATLAB interface. And if you notice on the right-hand side here, there's a little green square here. And if I wrote something bad in MATLAB, if I didn't write some good MATLAB code, there's going to be all these warnings on the right-hand side. So these are some of the cool interactive features that MATLAB has to offer. Interface. Now, a lot of times when you generate a piece of data, a lot of times when you process the data, visualize the data, you want to do something with it. Maybe you want to create a report. Maybe you want to create a document so that you can hand it off to your professor or hand it off to your boss, or maybe even present a presentation. Well, if you put the script into what we call cell mode, then what you can do is publish this file into various different formats. And over here, it happens so that we're selecting the HTML format. But we can also generate a doc, a PPT, etc. So I'm just going to go ahead and select HTML, and I'm going to say publish. And there you go, right? It's going to take a little time, but it's going to run through that code. And eventually, it's going to generate an HTML file that we can use as a report to show all of our colleagues, all of our managers, or professors. Here you go. So here, I have a nice little report. And there's hyperlinks, so if I want to look at the plot, I can click on it. Oh, there you go. I can look at that portion of the plot. Now, this is a very, very simple example, very small example. But if your code is 100 lines or 1,000 lines, can you imagine how useful this might be, right? This is a very nice feature for you to document your code. So I've created a script. If I wanted to, I could simply create a function, right? I can go here and use the function keyword, right? And then put in basically my function name, right? And then put in inputs and outputs if I wanted to, right? So I won't go ahead and write the function. Some of you probably already know how to do that. But what I did was, prior to this presentation, I've actually created another script that's a little bit more sophisticated. Let me show you that now. So over here, I have this is sort of your grandfather's MATLAB. This is the MATLAB that you're familiar with. But if you look at this MATLAB, it's pretty much function-based. What we're basically doing is we have everything in cell mode, and we're reading in a file, we're listening to it, I wanted to do that to wake everybody up. That's why I did that. And then add some noise. Let's plot the result. Right? So you see that I'm plotting all sorts of different results here. Right? I'm basically plotting a time domain signal here, and basically this is the noisy signal because I added some noise to my data. Now, that's nothing special. That's nothing special. But something that you may not be aware of, even users that have used MATLAB for years, sometimes they don't discover this button right here. There's a nice little button here that you can click on. And this is something called the plot tool. So a lot of us, use the plot command and, set the property of the plot by the command window. But there's an interactive way to do this, right? So with a regular plot, if you click on that button, it opens up this nice control panel. This is a nice control panel that you can interactively create sophisticated plots. So for example, if you're not sure what the command is to make multiple axes inside a plot, well, you don't really need to remember that. All you have to do is basically select these boxes here. Now you have a subplot. All right? If I wanted to, I can highlight, the object inside this plot, and I could change the color. I can change the axis property. For example, the x limits, the y limits, and by pressing that button, basically all of these properties are exposed to you through this interface so that you don't have to remember all the different commands. And you can really make some sophisticated plots based on this tool. I wonder, I'm just kind of curious, how many people know about that button? It's got to be one of you. This guy knows. But this button's been around in MATLAB for quite a while. Did you know that? So I hope that helps. And when you're done generating nice, pretty plots, you can say File, you can say Generate Code, and this generates a function that you can now call to create that plot with all the same properties that we've just interactively defined. All right, so if you look at it, this is the function that we just generated. And somewhere in here, it defines all the code that says, well, I want that first plot to be red, the second plot to be blue, etc. And you can save this off. You can save this function off. I can say create figure 2, save. And now if I close this function, I can call it. I can say create figure 2. That was the function that I generated automatically. And just give me a second here. I could do something like this, right? I generated some MATLAB code automatically through that interface. And now I can call this over and over again, right? So I don't have to write all those scripts. Let's continue on with this script that we were looking at. What else? I'll continue going through. Whoops. I put some noise here, and I listen to the noise. Now, how did I add the noise? I added the noise by using a function that I created. And this is basically a function. This is an architecture, or this is a format of a function keyword, and that's it. It's just a few lines of code, right? So I just called the function. Very, very simple. Now, continuing on, right? Down here, what we want to do is filter out our signal, right? We want to filter out our signal. So one of the things we can do is call this function to create the filter. Well, how did we create this function? This is a function, this is a filter function, but the way we created this filter is by using some signal processing tools, right? So there's a tool called FDA tool. Some of you may have used it before, but basically from the command line, if I type FDA tool, enter, what comes up is a GUI, a graphical user interface. And this graphical user interface allows us to create all sorts of nice filters, and all I have to do is basically fill in these blanks. And when I fill in these blanks, low pass filter, FIR, sampling, frequency, pass band, stop band, attenuation, etc. I can say design that filter. I can look at the filter, and I can do all sorts of different analysis, which I won't look at. But I can, again, say file, and I can say generate MATLAB code. Okay? And I could generate it saying my filter and now I have a filter function that I can call, and effectively, that's what we did here. That's what we did in this script that I showed earlier. Okay, so when we go back to the script, and when you scroll down, this filter function effectively was generated by using that FDA tool. With a simple few steps, we created the specification and we generated a function, and now we can call it. Okay? And then now we can listen to it and look at it again. All right, so hopefully that gives you a little bit of a warm-up to MATLAB. Now, if you don't know about some of these features, hopefully that was enlightening. If you did know about some of these features, it was just a little warm-up to get your head into what we're going to talk about the rest of the session. Let's talk about some of the new capabilities. Most of the capabilities we just talked about, they were function-based. Function-based capabilities. But there is this new paradigm that I'd like to kind of just talk to you about, and this is something called system objects. And I'll show you how to create one and use one, right? But system objects, again, is this notion that allows us to do object-oriented methodologies inside MATLAB. The key here is these methodologies allow us to represent dynamic systems a little bit easier than MATLAB. A lot of our customers do object-oriented design, and over the past few years they ask us, well, how does MATLAB support that? I'm a signal processing customer, I'm a communications customer, I'm creating a dynamic system, a comm system, and we like to do object-based design. Well, could MATLAB support that? Over the last couple releases, we enhanced our product so that we could do that. And the reason why it is a more natural representation of dynamic systems in MATLAB is that it has some of all the tasks that is required for system design. Now, when you create a system, generally the things that you think about is that basically you have sort of an initialization portion, and then you have sort of the in-the-loop portion. You kind of break up that two parts of a system, right? You kind of initialize everything, and then you do the in-loop processing, and then you terminate, right? So system object has the architecture, has the capabilities to allow you to do that. System object is faster. It's faster than some of the function-based capabilities that we have. And mostly it's because over the past few releases, we've spent a lot of time optimizing these objects. And then system objects allow you to actually implement C code from these MATLAB system objects. So in a sense, that also allows you to have a path to systems design. So that's a little bit about system objects. Let's take a look at where they're found. So if you type DOC in MATLAB, doc, right, that opens up what we call the documentation. In the documentation, if you scroll down to, for example, ESP Systems Toolbox, and it turns out system objects, as I said in my keynote, exists in 3 different locations. System objects we added to DSP Systems Toolbox. We added to the Communication Systems Toolbox. There's also system objects in Phase Array Systems Toolbox. If I look at the documentation for the DSP Systems Toolbox, you'll notice that here, hopefully everyone can see, something called system objects. Open it up. Look at all the different types of algorithms that exist as system objects. Now, keep in mind that all the functionalities before and the previous products, the function-based one, they're still there. They all are still there. But now, you can use this, and if I expand one of them, for example, sources. You see all the different sources, right, that we can access. Effectively, these are sort of packages, if you will, the DSP package, right? And it says DSP dot audio file reader, DSP dot audio recorder. These are sources. These are sources. And to use this, to actually create one of these objects, all you have to do is do this. Right? Let's suppose that we wanted to do that same code that we did in function-based MATLAB. All we have to do is go to our command window and type that. We can say H equals, and if I type enter, what I've just done was I've sort of instantiated this object, and now I can start using it, right? So this is just initializing this object. This object, so notice that it starts out with DSP dot something. This is the common API. Okay, whenever you use the DSP Systems Toolbox, and you want to use an object from that toolbox, you always say DSP dot something. And that something is the algorithm description. And then once you've created that object, now you have all sorts of properties that you can alter, you can vary, right? So if I go and say, well, if I wanted to look at some of these properties, and by the way, this is the default property, right? This is just the default property. But if I say H dot sample rate, for example, right? It returns that sample rate. That's how you access that value as you're programming. It's kind of intuitive, right? If you guys use structures and things like that in MATLAB, it's a very similar type of notion. else is there? Well, let's look at a simple example. What I just showed you is sort of the instantiation of that object, right? This object. But if you wanted to, you can take a shortcut. As you're putting that object together, if you're putting that object together, you can start to put in the properties, right? So if you wanted to read an audio file, then you can specify in a string here the audio file name. And then what you can do is then start going through and say, this is the property, this is the property value. Okay, so it's property value, property and property value pair. Similarly, output data type, double. So that's the basics, right? And different objects have sort of different properties, and you look in the documentation to kind of learn about these objects. Now, I picked these two properties to specify for a reason. Right? It's kind of interesting because system objects has sort of this stream, it allows you to do streaming, the streaming property. Now, when you're doing function-based MATLAB programming, a lot of times when you want to read in an audio file, what do? You read in that whole file, and you do batch processing. It takes up a lot of memory. Sometimes the memory crashes or whatever it is because your music file is so big or something like that, right? But these objects are nice in the sense that it allows you to do in-the-loop processing, streaming, if you will. So this property in particular says samples per frame, 40. So it's going to read this WAV file, but it's going to read it 40 samples at a time. So it's not going to read in everything all at once. It's going to read in, sort of 40 samples at a time. And it's all built into this object. Now you can actually do that in MATLAB already, previously, using function-based techniques, but you have to write your own sort of programs to actually index into, read some part of the file, allocate an array, put it into that array, right? A little bit painful, but this is kind of a little bit easier. It's all built in. So that's one of the benefits. An extension of that benefit is really about memory, right? You're not using nearly as much memory here than if you're doing batch processing. So this is kind of interesting. I also picked this data type for a reason, right? There's a field called output data type, and basically this allows you to set your data type. These objects allow you to do fixed point. So if you're doing all sorts of sophisticated fixed point design, you can do that. You can do that by simply saying output data type and then specify that data type. And then eventually generate implementation code for this object. Okay, so that's a little bit about instantiation. What about in the loop? So once you're in the loop, this is just creating the object. But if I scroll down, very simple. Very simple. Basically, while we're not at the end of the file, this is the object that we created up top. Well, we're not at the end of the file. There's a method called step that you can call. And this method is common to all of the system objects. This is what we mean by sort of simplifying the programming technique. So you can use step as a method, and this works with all of the system objects. And this is when you do your in-the-loop processing. All right. So here, now we're going to read in that file and play that file, and it's just going to do that repeatedly until it's going to read it 40 frames at a time, and it's going to repeat until we get to the end of the file. And then finally, we have to release the handle. This is a simple example, but hopefully it illustrates some of the benefits, and then at the very least, illustrates the mechanics of how you would use it. So I'm just going to execute this code. You can see I just created this object, these two objects. These two objects are, first of all, I'm reading in a file, and I'm playing a file. Right? And then finally, let's Now let's look at a slightly more complex example. So, a more realistic example, if you're doing audio processing, if you're doing video processing, or other sorts of signal processing, and you want to leverage this technology, really, this is probably what you would do. You know, you would say, well, you know, I have the initialization portion of my code. I got the initialization portion of my code. Look at all these initialization code. I want to create a digital filter. So I say dsp.digitalFilter, esp.audioFileReader. This is an LMS adaptive filter audio player, right? So this is initialization. And here, this is runtime. This is processing inside the loop. So let me run the first part. And in the loop, you see that the code format is very similar to the code that I wrote earlier. You can see the architecture. It's very similar. Now, if you write function-based programming, it varies from one engineer to another. It's just a little bit harder to follow, but this structure is certainly very clean, you know, and it's fast. So now let's go ahead and run the in-the-loop processing. And let's release. So that's sort of the essence of system object, and there's various different benefits you might take away from it as you're using it. But, you know, give it a shot, give it a try, see if it works for you. But if you look in here, right, all of the sort of the state handling, all the things that, you know, keeping track of indices, those are all gone. You don't need to do that anymore. So for those of you that are good at MATLAB, if you wanted to program something like this, there's a lot of, if you wanted to do kind of the stream processing, there's these indices that you have to keep track of. There's states you have to keep track of. It's a nightmare, right? This is all kind of packaged up for you. And remember earlier in the keynote or in the introduction of this system object, I talked about one of the ideas of system design. It's about abstraction. It's about sort of hiding some of the details, providing some of the capabilities that you can use, but hiding some of the details when you don't need it. And this is sort of kind of what system object is doing a little bit. Hey, does that make sense? That's a preview. And this is a new capability. This came out this year, earlier this year. I want to spend just a few minutes talking about a topic that a lot of people are interested in, which is acceleration. You know, I want to go through this quickly because I really want to get to the MATLAB Coder part of it, because I think a lot of you guys, my guess is you're interested in it. But the acceleration piece, I'll just kind of run through in slides, and I'll talk about some of the best practices. And if you have more question about it, we can talk about it offline. But I have some demos as well that we can use offline, right? But really excuse me, there's a little bit of an echo. I want to move this down. But acceleration, in my mind, there's many different best practices or methodologies, but in my mind, there's, you know, basically 4 or 5 different ways to accelerate MATLAB. Well, more often than none, right? More often than not, when I work with customers and I look at their code, they say, "Oh, my code is very, very slow." Well, usually there's some sort of bottlenecks that we can really improve on. Sometimes customers don't know certain techniques, right? So one of the things you can do is simply optimize that code. And a lot of times, you know, we spend a lot of times with customers to do that with them. There's also something called parallel computing. Parallel computing, Todd this morning talked about, and this is the notion that you can take your MATLAB code, distribute it onto multiple cores, of your machine here locally, or if you have a cluster of computers, you can also distribute your code, distribute your simulation onto the multiple cores or multiple computers on a cluster. Okay. What else is there? Well, there's better algorithms. There's system objects. This will also improve the performance of your system or speed. You can use the code generation technology to generate mechs, which I'll show you in a few minutes. And then finally here, you can generate C code. So actually, let me clarify a little bit. I think I was not very clear, so I want to clarify. You can generate C code using MATLAB Coder to create a mechs file, and that'll accelerate code. Or if you have very customized C code that's very optimized and fast, you can also put a mechs wrapper around it and bring it back into MATLAB. All right, so that's really what I wanted to say to kind of give you a very high-level, view of acceleration. I have other slides, but really, I want to get to the MATLAB Coder piece. MATLAB Coder is a very exciting feature for us. MATLAB Coder, well, first of all, how many people write C code? How many of you here write C code? And I bet you if I ask you guys, why do you use that C code? You'd probably give me different reasons, right? There's different reasons why you use that C code. What are some of those reasons? Well, you might be integrating that C code into your custom corporate simulator. You might want to, create a lib. You might be using that C code and compiling into an executable, right? For prototyping. If you're using MATLAB, you might rewrite that MATLAB into a mechs, or compile it into a mechs function to speed it up. Or you might be writing it to target embedded processes. So there's various different reasons to do that. And I'm going to show you MATLAB Coder, the different use cases of MATLAB Coder interactively. Okay? So let's take a look at a very, very simple example of MATLAB Coder. The simplest example in MATLAB is A plus B, right? Or A times B. If you have a piece of code like A times B in MATLAB, this example, right? And you want to generate code from this, I'm going to show you the mechanics of doing this, right? Through MATLAB Coder. First thing you do is you put a %pound fragment here, code gen. And what this will allow MATLAB Coder and the editor to do is know that whatever you write here is meant for C code generation. Next, if I come to MATLAB here, I can say File, New, Code Generation Project, and this allows us to generate a project. And I could say My Project 1, or anything I want to call it, and when I press OK, on the very right-hand side, what's available for me is this new MATLAB Coder panel over on the right-hand side. And this is where I can manage my project, control the way my code looks, right? So over here is my project. Over here are my MATLAB code that I'm interested in. We know that EX01 is A times B. Right? We know that that's the file that we want to generate code for. So what we do is we can just drag it over, or we can say add file. And now, this piece of code here is ready for code generation. It's very easy, right? Well, one of the issues with generating code from MATLAB to C is, MATLAB is sort of a loosely typed language. You can say A times B, A plus B. And C will come out. But in C, you can't really do that, right? You're going to have to tell it the size and things like that, right? It's more tightly typed, if you will. So in order for the coder to actually work, we have to tell A and B size. So one way to do that is go over here, and I could say define by type, and I could say I want a double precision, and I want to make it 4 by 4, right? Matrix processing. Same thing for B. Press OK. Oh, by the way, if you want complex, if you wanted to have complex support, you can click on that. And I'll just say OK. And, let's build this project, right? Well, before we build, there's different ways for us to, there's different sort of, different targets, right? Different targets. If you wanted to generate MEX for acceleration, that's the first option. If you wanted to generate a library, that's the second option. If you want to generate an executable, you can do that as well, provided that we provide the main.c, right? But that's all there. So let's generate first for MEX. So I could say MEX, and I could say build. And what this is going to do is it's going to generate the C code, compile it, and then it's going to generate the wrapper, MEX wrapper, so that now we can call that same function from within MATLAB, but it's the generated code that we're calling. And again, the motivation here is acceleration. So for those of you that have long BER tests, for example, long BER tests, you can accelerate your code this way, right? And here we go. It's done. And what else? Now I can basically say, if I create two variable inputs, and I can call it with my original function. There you go. I have the results. That's from the original function. But if I wanted to, what I can do is call the MEX file here. This is what I wanted the output name to be, so I have to match that. So I have to go over here, and I say _MEX. And this is the accelerated version. This should have the same results. Okay, so that's one way to actually generate MEX file. Hey, Kenny, I know that we're running late. We started a little bit late. Is it possible to kind of, I wanted to really show these couple of more examples. Okay, thank you. So that's MEX. That's the first use case. Right? What if you wanted to generate C, right? Standalone C code. Many of you probably want to do that for various different reasons. Well, let me show you another example, right? I'll show you the second example here. And I wanted to show you some code generation options that you might be interested in. So the second example I have here is kind of nice in the sense that you have a function a times b, or a plus b, right? But the second function here, second line of code here, is a call out to another function. I can right click, I can say open that second function, I'm calling out to it, this is all in MATLAB, and this has a matrix inversion, so that's pretty beefy algorithm right here, right? And I'm just calling the matrix inversion here. What to do now? Can I generate C code from this MATLAB code? The answer is yes. You don't really even have to worry about it. As long as it's in the path, your MATLAB path, as long as your subfunction's in the MATLAB path, the process is the same. Now, earlier I showed you one way to create a code generation project. There's another way. You can type coder, and that also is a text-based way or command-based way to kind of open up the project. So, there's two different ways to do it. I can say my project 2 . And now, I'm sure you guys know now, you guys are very smart, you know that I can drag it over, right? And now define my interfaces. I can define my interfaces. All right? And I can go and build if I like. But I want, this time, I want static library. I want to generate C code. All right? So let's generate the C code, but before I do that, there's all sorts of options. Right? I can say more settings here. And if you look at the settings, there's all sorts of different types of options that we won't go through today. But for example, if you want to add some comments, if you want to put MATLAB code inside the C code as comments, you can do that. Right? If you wanted to create a certain type of report, you can do that. Code generation report, you can do that. There's ways to incorporate custom code, right? Something that's interesting, right? MATLAB by default will generate some extra files that allow you to protect against your data. So if your algorithm has infinity values or divide by zeros and things like that, you want to generate code to kind of protect against those type of edge cases, you can do that. But for us, maybe we don't need it. So these are all the things that you can do. You can kind of uncheck those, right? And now we can build. We can build this MATLAB file. I selected the report generation option, which means that after this file builds, we're going to be able to look at the C code from the reports, right? It's taking a few minutes here, but basically in this report, we're going to have a lot of options. Let's take a look here. This is taking longer than usual. Build finish, finally. And here's the code generation report. This is a nice report in the sense that it shows your MATLAB code. It shows that sub-function that we called, right? There is a matrix inversion. But over here on the right-hand side, we can say code gen, or C code. And on the right-hand side, these are all the different files that it generated. And we can look at the C code. We can look at the example.c, for example, example02.c, and this is what the C code looks like. This is the code we just generated. And if we scroll down, you could see A plus B here, right? And what's nice about it is there's also that subfunction, inv.c. automatically generated for you. Now this is a little bit more complex, right? So you see the various for loops as we're going through the matrix, trying to do the operations. It's all automatically generated for you. we have plenty of other more options that I can show. And Kenny, I think I'm almost out of time. Am I out of time? I wish I had more time because I have many examples. But, we only have 40 minutes. But please come talk to me. I have everything on my laptop. I can spend plenty of time with you. This is just a teaser. All right? So please, come talk to me when you have a minute and we can show you more.
Okay, thank you, Frank. 谢谢各位Frank 的presentation。